Welcome back to this very first and final video in Python mini course on machine learning. And really quickly before we get into this, I got a couple of things I want to review from the last video, or just in case you didn't look at the last video. But one thing we have to kind of understand is what's the steps we're going to follow. And in this case, what we're going to do is we have to import some data. So I've created some false data, and we will import those as a CSV file. Okay. And then the next thing we have to do is actually clean up this data. And again, from there, we're going to split the data into two groups. We're going to have our training set and our testing set. And then after that, we're going to create a model of the data that has been cleaned and split. And then we're going to train that model. Okay, and then the most important thing is, which is the whole point of this, is we're going to use this data in our algorithms to make a prediction. Okay, and that's really what the heart of machine learning is to make predictions. And then finally, once we've got comfortable with the predictions, then we're going to evaluate the predictions and then improve or optimize the outcome. Okay, so let's go over and look at the data that I want to use. So really quickly, this data is about movies, and I have it broken up into age, gender, and genre. And so the age categories that I have are between 20 and 25. And for male, we're going to say male is a 1 and females are a 0. And the way the age categories break up in terms of age, gender, and genre is that if you're a male between 20 and 25, you prefer sci-fi, science fiction movies. If you're between the age of 26 and 30, as a male, you like action movies. If you're between the age of 31 and up, then you've kind of evolved into just wanting to watch dramas. Now, if you're a female, you are between the age of 20 and 25, you prefer to watch fantasy kinds of films. If you are 26 to 30, then you're more interested now in romantic comedies. So we'll say rom-coms. And then finally, if you're 30 and over, just like the men, you prefer just to watch a drama. Okay, clearly these are just outrageous generalizations, and please don't send me hate mail. Okay, they're just an example set of data. That's all they are. Okay, and I have gone into Excel and I've saved this as a CSV. Okay, so it's movie machine learning.csv. And now what I need to do is actually bring this now into my Jupyter Notebook. So I'm back in my Jupyter Notebook file management system, and I'm going to upload this video. And there it is in my directory. I'm just going to upload that and open it. And right here, you can see that it just appears, but it's not in there yet. I have to select the upload button in order for it to be brought in. And you can see it's right here. Okay. So now I know I've got confirmation it's right inside my file. And now I want to go back to my new Jupyter Notebook environment. It's called First Machine Learning. And the way I do that is I actually just click on that link. And it opens it up here in my local host 8890. And you can see First Machine Learning, and it's a blank file right now. So at this point, the first thing I need to do now that I have it is I have to actually import that CSV file into my Jupyter Notebook. Now, the way to do this is we do import pandas as PD, and PD becomes our short form so that we don't have to keep typing out pandas. And then it is pd.read underscore CSV, and we put this into this function call. And the name of the file was movie_ml.csv. And what I want to do now that I can do this is I want to say, I want to change it to movie_data. And we're going to initialize movie data to that file that we just created. And now let's just go and have a look at this movie_data. Okay, and let's just run that. Okay, you can see that it's all there. All right, so if you've gotten to this point, this is really good. So now that we've imported the data from the CSV file, the next thing we need to do is clean the data. So let's go do that now. So fortunately for us with this data set, there are no duplicates to our records. It's relatively clean on its own. It's relatively straightforward. But one thing we have to do with this is actually break it up into two sets. Okay. It's relatively forward, and one thing we have to do is actually break this up into two separate sets. And the way I'm going to do this is I'm going to have my first two columns as my input set, and then the last column is going to be the output set. Okay, so we're trying to make a prediction on whether or not, based on an age group, they are going to choose a certain genre of movie to watch. Okay, so we're going to use the inputs from age and gender to predict what the output is of the genre in the movies. Because when we train the model that we want to create, we're going to give it two different sets. We're going to give it the input set and the output set. Now, I want to point out something here in that really we could do this in very, very traditional, not even object-oriented programming ways. We could just basically do if-else conditions, and we could say if an age group is between 20 and 25 and it is identified in genre 1, just return a value of sci-fi. We could do that. That's pretty standard. But suppose there are many, many different, let's say thousands, hundreds of thousands, millions of records, and multiple categories here, not just age, genre, and gender. Okay, so, we could do this traditionally, but in reality, this video is about machine learning. Okay, so what happens if we have a 21 or 22-year-old male? We want to predict what they're more than likely to want to watch as their genre of movie choice. Okay, or a female that is between the age of 25 and 30, but maybe we don't have a record of her actual age specifically. So let's say right here, a 26-year-old or a 28-year-old female. Okay, so yes, I acknowledge that we could do this in traditional methods, but really we're trying to make predictions, okay? And that's really what the point of machine learning is to make predictions. Now, the first modification I want to make is I'm going to call this drop function, okay? And if you put your mouse over top of it and press Shift and Tab, what happens is you're getting this description of what we need to have inside this parameter. So let's maybe open that up a little more clear, and we can see all of the parameter list that is inside this drop function. Okay, and we're interested in this columns right now. That's the one that we're really interested in. But of course, you could go through and read some more single label or list like alternative to specifying access and stuff like that. So you can read through those things, and I do encourage that you get into those. Now, the reason I'm interested in that is because I want to drop the genre column. Okay, so the way I'm going to do that is just say columns and set that equal to, and this is going to be in square brackets and in quotes, genre. Okay, so that's how I'm going to drop this column from the table. And let's go ahead and run that. And you can see now that it's dropped that from the output. And let me close this. And what I want to do is actually change this a little bit, and we want to represent this by capital X. Okay, so that is now X. Okay, and again, just if I want to go about inspecting this, I could have run it, but in this particular case, I'm going to rerun this again in this particular format, because I want this entire thing to be initialized. I want X to be initialized to all of this. Okay. And now ultimately our input set is represented by X. Now, in order to see what we just took out of there, the genre, what we're going to do is say, okay, how about movie underscore data? And this is just simply going to be like this, genre. I'm just going to type in genre, but by convention, what I'm going to do is for my output is lowercase y. Okay, so my input is uppercase X, my output is lowercase y. Okay, so let's have a look at this. Okay, so now we're seeing just this column here. That's the output we're looking at. And now that we have our input and our output, the next thing is let's create a model and choose an algorithm. So in the last section, we actually cleaned the data, and we also split it into the two groups. Okay, so in this part, what we have to do is now go over and create the model and choose an algorithm. So here's a really good thing. Data scientists and machine learning engineers, AI engineers, and PhD researchers, and all sorts of people in this field for years have been developing these algorithms. And we're going to use one called a decision tree, and which is great because we don't have to build this thing from scratch. We can almost call it like it's just a function, right? So think about it. Somebody has developed a way already to process this. We just have to input our data in a way that is useful to that particular algorithm. Okay, so we're going to use a decision tree on this. And the way we're going to use that inside of Jupyter Notebooks is with scikit-learn. Okay, so let's get in and I'll show you how that works. So right here at the top, right underneath our pandas statement, going to give ourselves a lot of room. So we're going to say from sklearn dot tree import decision tree classifier. Okay, and that's what you want to have on this particular line. And this is how, like we've talked about in previous Python videos, how we're going to be able to use or implement these tools. And the package that comes with scikit-learn is right from here. Okay, and scikit-learn has this module called a tree, and we talked about that before, that the module is just another name of a file inside of that. And then we have this class. Okay, and this class is what implements the decision tree algorithm. Okay, so really what you're seeing is this is our package, this is our module, this is a class that is inside that module, inside that package. So we are actually now going to instantiate an object of the decision tree classifier, and we're just going to simply call it a model. Okay, and now we are going to call, or this is how we instantiate an object of decision tree classifier. So instead of typing that all out, what I'm going to do is I'm just going to copy it and then add my brackets there. And this is how I'm now creating a model of this, or a object of Decision Tree Classifier. And now that I've created the model, in actuality, I haven't created it. I've just made an instance of the model. The next thing I need to do now is to train this model. Okay, so let's go back in and do this. So what I need to do now is I'm going to call this function called the fit function, and that's something from the class Decision Tree Classifier. Okay, and we're just going to do model dot fit, and this takes two parameters. This takes our capital X, our input, and our output, so X and Y. Now, before I ask the model to actually make this prediction, just keep in mind, like what I said earlier about the fact that traditionally we could have just done a bunch of if-else statements. Okay, but you know, we looked at the data and we realized that right here, we don't have, for example, a 22-year-old male who likes sci-fi. We don't have a record of that. So we're going to ask it to make the prediction for this. Okay, and that's really what the point of this is. So the way I'm going to do this, which is great because I can, you know, literally I'm calling these algorithms and it's doing all the heavy lifting for me. So what I'll do is I'll type in model.predict. Okay. So this function here takes a two-dimensional array. Inside this here, I'm going to do a two-dimensional array. And what I'm doing is just creating the square brackets, and then inside I'll create another set of square brackets. Now in this center or inner set of brackets, what I'm going to say is please make a prediction based on a 21-year-old who is a male. And I can ask it to do another one by saying, okay, give me a 22-year-old. Let me see if I go to my model, what don't I have? I have a 22-year-old female. Let's go with a 23-year-old female. So a 23-year-old female. And then we're going to, once we've created that, we're going to create a variable for this, predictions, and initialize all of this to predictions. And now let's inspect that. And the way we'll do this is just do this. And let's run this. And you can see I've got an error here. And it tells you different locations that I might have this error. And if you didn't see it earlier, it was actually right here. I have an imbalance with my brackets. So I have to put this bracket in here and run it again. And I still have an error. And let me just clean this up, because you can see is does not match opening parenthesis. And I keep these errors around sometimes just to show you that you really need to be very diligent and careful when you're dealing with brackets of any kind. If you get an imbalance in the number that you have, you're going to get errors. And if you know, 9 times out of 10, when it comes to errors involving arrays or lists or anything, it's probably something to do with the imbalance of actual brackets. So I made that actual prediction. And what am I getting here? And what this is saying is that a 21-year-old male likes sci-fi. A 23-year-old female likes fantasy. So as great as that is, you could almost say that maybe we got lucky, or maybe our data set is too small, whatever the reason is. What we have to do next actually is come up with a way to measure the accuracy of what we're doing. Okay, and that's what we're going to do next, measure out our accuracy. You can see here on this slide, one of the things that I had when I said I was going to split my data into 2 groups, well, that's somewhat true, but not entirely. And so what we're going to do is, now that we've created the model, is we are going to now train that model. And this is where we definitely do want to reconfigure and set up the training set and then the test set. This is how we want to determine our accuracy of our model. Okay. So the rule of thumb is that typically your training set is about 70 to 80% of your data. And then your test set makes up the remainder of that. 70 to 100% is your test set. Okay, so you have the what you're going to send through and test it. And then once you're happy with it, you're going to use the rest as sort of a confirmation that your algorithm is functioning the way you want it to. So the goal is to take the predictions and then evaluate that against the test set. And that's how we can get our accuracy. So let's go get another package from sklearn. So this is going to be from sklearn dot model underscore selection. Okay, and it's import train underscore test underscore split. Okay. So this is what we're going to use for training and for testing. So right here underneath this is we're going to call this train test split function. And I'll put that here, and it's actually a function call, and we need 3 parameters. So we need x, comma, y, and then the next one is something called test underscore size, and we're going to initialize that to 0.2. Okay, so this is actually now going to be a tuple. Okay, so I've got my test data size, or my test set is going to be 20% of the total. And because it's a tuple, I've got x under train, comma, capital X, test, comma, lowercase y, train, comma, and lowercase y, test. Okay, and this is what we're initializing it to. So we've got train, test for both sets. So you have the input set for training and testing and the output set for training and testing. So we need to go down here and modify this one because at this point we're training. So we want to train this one and then again train this one. Okay, so your fit should be modified. And now we need to change this because we're not going to explicitly tell it the 2 that we want. What we want is the entire set. So this one is going to be our X. Sorry, I got to get rid of the actual bracket. So this is going to be X underscore test. Okay. Now to calculate this prediction, what we have to do is compare this predictions to the actual output of the test. Okay, and this is how we're going to be able to calculate this accuracy. So the beauty is we don't have to do anything complicated. We can just do this import from sklearn dot metrics, import accuracy. Just want to make sure I spell it right because as you probably have guessed by now, I'm terrible at typing and talking. Accuracy underscore score. Okay. So now in order to use that, what I can do is actually now call this accuracy score because it's a function. And what I'll do is put that here and pass it 2 parameters. And like I said before, we want this one here as our first parameter or our first argument, and then this one here. So the accuracy score here is going to be between 0 and 1. Okay. So let's assign that to score and then really just display this to the console. And let's run that. Okay. Now, this function is constantly selecting random data in testing sets. Okay, so each time that I do this, it's going to grab a different data set and it's going to make this random prediction. So right now we're at 1, but if I continue to run this, it's going to repeat the cycle. And you can see right now we got a score of 0.5 or 50%. I want to show you a little shortcut about Jupyter. When I ran this, it created this little box at the bottom, and it can kind of be a pain in the butt. So one thing you can do is you can go to here, and if you remember from the last video, we're in this active window. What I can do is actually, I have a shortcut in order to do this. And basically all you have to do is make sure that it is go Control and Enter. And do it again. Okay, sorry, I meant to say green, but it really should be in blue. Okay, so I'm just going to highlight this, Control, and I can do Enter, Escape, sorry, and then while I'm in there, say Control Enter, and it's going to keep running it. All right. So the goal of that is just to run the current cell without adding this one below it. So we're getting a relatively high value here, but suppose I change this to say 70%. So my test size is now much, much bigger. And if I go to here and, sorry, I run this again, you can see now my output score is dramatically changing. Okay, and if I run that again, it's pretty low. It's on the low side of predictability. So I don't think I like that output. So if I run it again, look at that. I'm down at 0.38, and one more time, I'm back up to 0.53, so 5.4. So it's all over the place, and it's because of the difference in size between my training and my testing. Okay. And the reason is because I haven't done enough training yet. Okay, what I'm saying is, hey, do 30% of all of my training data, and then let's test it out. Okay, which is exactly what we don't want. We want to have a large training sample, and then we can do the testing. Okay, so we're back to 0.2, and I think what I should be doing here is running that one more time. And now we're back to 1, okay? And I want to caution you about one thing here. And, I can keep running this. And you notice there, I just flicked through, it was 25% and I think a 75%. I can just keep running that. And you can see here, even though I've set this to a 0.2, which means I'm training with 80% of the data, I still only got 50% accuracy. One of the issue is that my actual data set is only like 18 records long. That's not a lot of data. So put that into perspective. If you're trying to learn how to drive a car, okay, let's say even a race car. Okay, you can't just go around the track 18 times and be ready to become a professional driver. You need thousands and thousands of laps to become really, really good at this. Okay, so this is the issue, is that we can't really train our data if we don't have a lot of records. So, having a lot of records is extremely important to getting a good, accurate prediction. So what I want to do next is actually switch gears and spend some time now talking about models. Okay. So I've gone ahead and I've cleaned up this, the code that we were just previously working on, because we're just really going to focus on models for a little bit, on persisting our models. So every time we get a new user, or every time we want to make a new recommendation, we don't want to have to keep rerunning this entire block of code. if this wasn't such a small data set, it wouldn't be that time consuming. But so if we had hundreds of thousands or hundreds of millions of records, it could possibly take hours to actually run these predictions. So we need to make a change here because of that. So one of the things we can do is we'll build the model, and then we'll train that model, and then we can save that model that has been trained to a separate file. And what it means is if we want to make a future prediction, we just load the model that has been trained, and based on that trained model, we seek a new prediction. So if we want to save and load models, we can use the Joblib object. So after we've trained our model, now we want to call this object. So joblib dot dump. I'm having a hard time spelling today because it's not even 6 o'clock in the morning yet. So joblib dump, and the first parameter or argument is model. And then we want to call this movie recommender and save it as a joblib. So the extension, it looks like it's an extension, but we're tying it to joblib. And let me change this. Instead of an underscore, we'll do this as a dash. So this becomes the name of the file that we want to now store the model. So in essence, we're dumping it from this particular project file right now. We're dumping it, and we're actually dumping it into this file. Okay. Okay, so temporarily, I'm going to comment this out because at this point, I don't want to make a prediction. What I want to do is basically train this data set. And once it's trained, I want to dump it into movie recommender.joblib. Okay, so let's go ahead and run this. And you can see I have this error. Now, there's an issue with this is that sometimes things become obsolete. Sometimes things become out of date altogether, and Python has made some changes. And so it says right here, cannot import name joblib from this file. Okay, and if you go and you look it up on something called Stack Overflow, or AKA Snob Overflow, because there can be a lot of angry people on there from my experience, what it talks about is a whole section here about this becoming out of date. Okay, so what it's recommending is that we just go to import joblib and we just kind of forget about all the rest of this stuff here. So we just do an import joblib. And so in order to become more current or up to date, what we can do is just take this and do import joblib. So let's go back into our code and we can get rid of all of this stuff because Python or Jupyter is no longer handling code in this way anymore. Okay, so this is going to be something where you think something's going to work today because it worked yesterday, and you show up and there's been changes in the background to the developers of the software platforms that you're using. And this is an example. Okay, so I'm going to save that and then I'm going to run this code. And you can see now that I have my movie recommender.joblib file. Okay, so if I go out to my documents again, you can see the file is right here now, okay, on this line. So we know that that actually worked. So this is an array of our output file. Okay, so we're doing good despite the small error. So what is this exactly? This file is now our trained model. Okay, so, we're going to have to hold on to this because we're obviously going to come back to this file. So doing all of this here would be somewhat redundant at this point, right? So if I comment all that out there, just like this, and I select Control/, now I'm commenting out all this code. And down here, we're not dumping into a file anymore. Now we want to load it. And of course, we don't have to load this parameter here, this model. We're just trying to now load movie recommender into our application. And then we can take all of that and assign it to a model. And the reason I want to assign it to a model is because you can see down here, I want to use it now. So where in the past, we divided it up and we trained it, and then we tested it out to make predictions. In this particular case, what we're doing is we have access to the trained model in another file location, and we're just taking that entire thing, we're loading it and then assigning it to model. And now we're going to make a prediction based off of model. So previously we said that men between the age of 20 and 25 liked sci-fi. So let's go ahead and test this out and see what it says. And you can see in this particular case, yes, it actually predicted correctly. So what we've done there is now read our model that was trained from an external file and then manipulated it inside the application that we wanted. And we got the right prediction in this particular time that we've run this code. Okay, so the next thing I want to do is I want to go and look at this in a visual manner. Let's go see what, visualizing this decision tree is really going to look like. Okay, so let's go try that now. Because decision tree classifiers are really one of the easiest algorithms that you can do in machine learning, that's kind of why we're starting there in doing this problem here. But now let's go and have an actual look at this. Let's kind of test this out. And let me just clean up this code for a minute. Okay. There. And I also want to take out this and clean that up because I like to really honestly work in a much more clean environment. So just to really quickly recap, okay, we're importing our model. We are dividing it between an input and an output, and we're just running this training, and that's all we've done so far in this section of code. So my advice to you right now is, if you've never done this, is just to do it exactly the way I do it, and don't worry about the why so much, as just try to get it to work. So up here, I'm going to do sklearn import tree. This tree object has a method for graphically representing our data. So what we need now to do is call the method from the object tree.export, and these are obviously methods that come from this class or from this object tree. So just kind of go with it, okay? So graph viz or viz, graph viz. And we've got so far 2 parameters that we want to pass. And the first one is our model, comma, and then output or out underscore file is going to equal to this movie dash recommender dot dot. Okay, and the next one, what we want to set is, of course, after the comma, is going to be feature underscore names. So these are going to really be the columns that we're interested in having an output to. And this is an array. So it will be age, comma, and gender. Okay. And let me clean that up a little bit. Like I said, it's really early in the morning right now. Okay, so this next one, and what I think I'm going to do is put a comma and go down to the next line. And this one, we want all the different class names. So for example, sci-fi, comedy, rom-com, all of those. But I don't want to type out all that stuff. So what I'm going to do is do some shorthand, and we'll do it like this. Class underscore names is going to equal, remember this. So we're actually interested in this Y, okay? And so we're going to do Y dot unique. Okay, unique. And remember, that's a function. And because I want it to be in the right order, now the next thing I can do is say sorted and wrap all of that into a function. Okay, so my class names will get everything that is unique, because you remember from our actual database or even our Excel spreadsheet, sci-fi shows up 3 times, rom-com shows up 3 times. So we want one of each is really what I'm trying to do. The next parameter after that is actually going to be our labels. And we'll set that to all. Okay. And what's next? And let's go down to the next line again. And we're going to say something like this. Rounded equals true, comma, and it's not rousted, it's rounded. And then filled is going to be to true. Okay, and that's it. So let's go ahead and run the cell, and hopefully I didn't impose any or introduce any new errors. So if I run this, you see I do have one syntax error, and let me fix that. And so far that was a simple one. I was missing a quotation here. Let's run that. I have another one. And this one says unexpected EOF or end of file while parsing. And what that kind of indicates to me is that there's an imbalance somewhere in my bracketing. And if I go up to unique, I think that that's where that issue happens to be. And it will change sort of the balance of my brackets. And you can see this one turned to green. And let's try that one more time. And great, it actually did. So let's go out to our documents. And what do we have here? We have the file that we're looking for, this movie recommender dot. Okay, and that happened just seconds ago. So that's awesome. So what I'm going to do is actually, I'm going to open up Visual Studio Code in a brand new file and go into my file explorer, and it'll be open file. So I'll do that and bring it into the project. So another way, if you're having a problem, is you can go here in your file explorer inside of Jupyter, and you can go to movie recommender dot. Make sure you're at dot, not the .joblib. Okay, and you're going to go ahead now and hit the download on that, and it's going to download. And now that I'm back in Visual Studio, what I can do is open the file, and I go to my downloads, and you can see it's right there, and it's a dot file. So there's going to be a lot of really ugly looking text, and it doesn't accept this file extension. So what I want to do now is go to my extensions, and I'm going to type in dot. Okay. And it's this second one right here that I want to have. Now, before I do anything else with this file, I want to just scroll down, and you can see some of the short keys. Okay, so right here, when I get this all set up, I want to remember this Control-Shift-V. Okay, because I'm going to need that when I go to look at the code here. So if I go back into this, into my file here, and I do this Control Shift V, you can see that I get this window now. And this is the zoom. So I can zoom out there. And now I'm actually getting a visual representation of everything that my entire decision tree. Okay, and I'll zoom that out just slightly more so the icons aren't in the way. And let me close this here. Okay, and let's go through what this says really quickly. I'm also going to close the this file here so that I've got just more screen space. And let me zoom out just a little bit more. And notice in this decision tree that every parent node at the top only has 2 child nodes. Okay, and if you look at this one here, there's only 2, and it further breaks down into 2 each. Okay, and if we look at this condition here, it says if the age is less than or equal to 31, then what happens? So if you look at this, what it really means is if their age is less than or equal to 31, go down this path. If not, it means that they're actually older than 31. So then automatically go down this path and select drama. Based on your user profile, we're going to select drama. And if not, then we have these other options, right? So it's saying if you're less than that age, go to action. And now what if you fit into a different category again? If you look here, we've got less than or equal to genre, and again, less than or equal to genre, but there are differences here. Okay. So to go down one more level, if we're saying that we're into this age group, and then we've got really true on the left and false on the right. And you can follow this path all the way down until we finally get to these 4 scenarios. Okay. So anyway, this is the way our decision tree is best able to make a really good prediction about what the likely probability or prediction that given our set of inputs, we get the right output. So if you look at, say, some of these numbers, like y is at 31.0, 26.0, and the reason is because our data size, our sample size is so tiny. These will update as we continue to have a much, much bigger sample size to train our data. Okay, so those numbers will get modified. And clearly, the more columns that we have within our decision tree, the more complex this becomes as well. And, you know, we've only got very few columns in this entire sample. And of the features that we have, we've only got 2 features, right? Age and gender. That's the only 2 features that we have. So finally, I just want to recap what we've done here in this particular video. Is that, you know, we have imported the data, we've kind of cleaned it up the way we want, we've split it into 2 groups, we created this model and we trained the model, and then we made predictions and we looked at the accuracy of those predictions. But, you know, this is a constantly or evolving process that you want to go to, because finally in the end, what you want to make sure that you do is that evaluation and then the improvement of your prediction. And clearly, the more data sizes, the more experience that your application gets. You know, it's like the difference between driving a car on your very first day versus somebody who's been driving a car for 30 years. Okay, so you want to constantly evaluate and improve that model. Okay, so anyway, just really quickly, that was a short and very brief introduction to machine learning using Jupyter Notebooks and some of the imported tools. And it was really just meant to complement what we had done in the previous Python classes or Python videos. Anyway, I hope you enjoyed that. It's really the tip of the iceberg and nothing more, just a sample. Anyway, thanks for watching, and I will see you in some future Python programming video. So thanks again, and I'll see you soon.